The Earth is a massive sphere of semi-molten rock, with an iron core as hot as the surface of the Sun. Vast amounts of heat, left over from its formation and the radioactive decay of countless tons of elements, have only one escape route: upward. Currents of rock spanning thousands of kilometers carry this energy to the surface, where Earth's crust stands as the only barrier. To us, the crust feels solid, but it is merely a thin shell around a fiery giant. True apocalypses can breach this barrier, unleashing eruptions exponentially more powerful than all of humanity's nuclear arsenal combined. These events can alter the climate for centuries in a single year, drowning continents in toxic ash and gases. Supervolcanoes. How powerful can these supervolcanoes be? And could they end humanity? Volcanoes come in various forms, from towering mountains to lava domes, but they originate mainly from two sources. The first is the boundaries between tectonic plates, the pieces of the crust that cover the Earth like a jigsaw puzzle. There are 7 major tectonic plates and dozens of smaller ones, drifting against each other at up to 15 centimeters per year. On geological timescales, this is a titanic struggle, where the winning plate forms new mountain ranges, and the losing plate is pushed into the hot asthenosphere at 1300 degrees Celsius. Despite the intense heat, the asthenosphere's insane pressure keeps it a superheated solid. Tectonic plates in contact with water for millennia absorb it. When they are submerged, this water triggers chemical transformations that melt portions into magma. This liquid magma, being less dense, rises in furious bubbles, accumulating in sponge-like reservoirs under the crust. When enough magma collects, it becomes powerful enough to break through the crust, creating volcanoes. The second source of volcanoes is thought to be mantle plumes, columns of abnormally hot rock rising from the core mantle boundary to the surface. Much is still unknown about them, but they act like weather patterns in the Earth's mantle, forming volcanic hotspots independent of tectonic plate movements. Volcanic Explosivity Index, VEI. Measuring the boom, scientists measure volcanic eruptions on a logarithmic scale called the Volcanic Explosivity Index, VEI, which quantifies the volume of ejected material. For instance, a VEI-2 eruption could fill 400 Olympic swimming pools with lava, and we see about 10 of these per year. At VEI-5, eruptions release cubic kilometers of debris, as seen in the 2022 Hunga Tonga Hunga Ha'apai eruption, which caused global tsunamis. VE6 eruptions, like Krakatoa in 1883, can alter global climates, producing the loudest sound recorded and cooling global temperatures by nearly 0.5 degrees C. VE7 eruptions are millennial-defining events. The 1815 eruption of Mount Tambora produced 400 times more energy than the Tsar Bomba, blanketing the skies with ash and causing a year without summer, leading to widespread crop failures and famine. What are supervolcanoes? The term supervolcano is a media invention, not a scientific one. They are characterized by waiting hundreds of thousands of years to erupt. Pressure builds in colossal magma reservoirs several kilometers deep, eventually lifting the surface rock until it cracks, releasing billions of tons of gas and ash at supersonic speeds. These super eruptions are like a boiling pot popping its lid, after which the ground collapses into the void, forming a caldera. The most recent super eruption was the Oroonui eruption in New Zealand 26,500 years ago, releasing enough material to cause abrupt cooling in the southern hemisphere. However, the Lake Toba eruption 74,000 years ago was far more significant, triggering a volcanic winter that possibly lasted 10 years, followed by centuries of droughts. The dreadful potential of volcanic eruptions. While supervolcanoes have a fearsome reputation, they are not an immediate threat. The chance of a VEI-8 eruption in the next few hundred years is less than 2%, and it would not come as a sudden surprise. However, less powerful but more frequent eruptions pose a greater concern to our civilization. By monitoring magma reservoirs for signs like ground swelling and temperature increases, we can get early warnings to save lives. In the future, we might even harness the geothermal energy of these giant magma reservoirs for good. Despite the churning hell below us, we have the ingenuity to find solutions, just as we have with other natural disasters. So, while supervolcanoes are a force to be reckoned with, Humanity's resilience and innovation offer hope.